Okay, hopefully you finished those up. Checking your answers, here's what you should get. One of the things to take note of, and this is the factor theorem, that it is if the remainder is 0, we know this. If the remainder is 0, that means we found a factor. That means, in this case, so x minus 1 is a factor. If I were to actually try and factor this maybe the old way, I would get that factor. Or if I were to divide, it would divide evenly, and I would have the factored form of this original polynomial. Okay, so that's kind of what that actual factor theorem says. Now, flip to the next page. For me, get the next piece of paper. Thankfully, we don't always have to do that long division. There is a shortcut. The shortcut's called synthetic division. If I'm dividing specifically, if I'm dividing by one of the factors in that form, x minus k, I can use synthetic division, but only if that's the case. Okay, and in this case, it says divide this polynomial by x plus 2. X plus 2 is in the x minus k form. What is k? Okay, hopefully you recognize that k is negative 2. That will give you x minus a negative to give you your plus 2. When we're doing synthetic division, it's much shorter and it's nice, but it's a little weird, so we have to get used to the setup. The way we set it up, and we'll just put this off to the side here, is we draw kind of a long L. It's our chart. To set it up, we put the k on the left side. There's room for 2 lines of text here, 2 lines of writing. In the top row, we write out all our coefficients and our constant. And just like the long division, use zeros for missing terms. Oops, sorry. Use zeros for missing terms. So if there's no x squared, put a 0 where the x squared would be. That's our setup. So let's start by setting this one up. Room for 2 lines of text, the negative 2 on the outside, the coefficients, so the 3, the negative 2. Okay, we have x cubed, x squared, x to the first, constant. So there's nothing missing, so I don't need a 0. A 1 for the x, a minus 1 for my constant. That's to set it up. Now here's what the process looks like. First thing, bring down the first coefficient. Okay, so take this 3 and simply bring it down underneath the chart. Then we multiply the k value with the number under the chart. Okay, negative 2 times 3 gives me negative 6. Put that answer in the second row. Put the answer in the second row. Okay, then we add down. So negative 2 plus negative 6 is negative 8. And then we simply repeat till we fill up the whole chart. So, repeat, I should say, number 2 and 3. No more bringing down. So negative 2 times the negative 8 gives me 16. I put that in the second row. I add down to get 17. Negative 2 times 17 is negative 34. Add down to get negative 35. What we found at the end is our final answer, but we have to build it up and make it into a polynomial. First, box off the last value. This is your remainder. Then we have the constant at the end, the x to the first, next, x squared, next, and if I keep building, if there was more terms, I would have an x cubed and however many I need. Okay, what we got when we divided, so let's go back again, fraction form, the answer to the division. We got 3x squared minus 8x plus 17. And then we have this remainder of negative 35. So plus a negative 35 over what I divided by. And what I was actually dividing by is x plus 2. That's the answer to the division. But again, that's often not what we're really doing. We often are using division for something else, mainly for factoring. So we're going to write the factored form, this polynomial form. This original 3x cubed minus 2x squared plus x minus 1 can be written as x plus 2, what we divided by, times the answer we got, 3x squared minus 8x plus 17. That's almost all of this, but then there's this remainder, so I need to, in this case, subtract 35. If it was a positive 35, I'd add 35. And if I were to multiply that all out and subtract the 35 away, I would get back to this original polynomial. Okay? That's the skills, the process you need to be able to do. Let's put it within context. Let's actually use this to find zeros. So here we have a polynomial, for example, 4. It's cubic. It's a large polynomial. Maybe you remember grouping and you could actually factor this without using this, but we're going to go with using our skill here of dividing to help us to figure out how to factor this and then actually get the exact value of our irrational zeros. So we go to our calculator. We don't have any zeros. Some of the problems in the book will say, here's your zeros. Okay, here's some rational zeros. Rational means they're not radicals. They're actually nice numbers that I can work with. So here we're going to put in 2x to the third minus x squared minus 4x plus 2. Oops. X plus 2. Okay, we want to find the real zeros. If they're all nice integer numbers, I graph it, I get my answer, and I'm happy. Especially if they're all nice integers or rational numbers. All right, so I looked at it. It doesn't look like any of those go through nice whole numbers. So they're definitely not whole numbers, but hopefully at least one of them, and we need it to happen for us to be able to do this, at least one of them is rational, where I can write out the exact form of it. So let's calculate our zeros. Okay, let's try this one on the left. Left bound, right bound, yes. Not an exact value that I can write down. On to the next. Calculate 0. I need to go to the left of this next 0. All right, I'm to the left of it. Move past it so I can move to the right of it. Make a guess. Ah, that's a nice one. 0.5. Great. We have 1 0 at 1/2. Okay, I'm going to go fraction form there, but 1/2. It's rational. I can write it out exactly. The other one, you can take my word for it, you can try it yourself, is irrational as well. So we've got one nice 0. The other two are irrational. If they were rational, I'd write them down and I'd be done. But because they're not rational and I want the exact form, we need to do some work to find it. So if I have a 0 at 1/2, then I know I have a factor of x minus 1/2. So I could take this polynomial and divide by x minus 1/2. It's in the form x minus k, so I can do synthetic division. Put my k on the outside, put my coefficients along the top. If you think you got it, pause it and go through and try it yourself. If you're stuck or not quite confident, here you can work through it with me again. Okay, first step is bring down the 2. Multiply. Add together. -1 and 1 is 0. Multiply to get 0. Add down. -4. 1/2 times -4 is -2. Add down 0. Did that pretty fast because I'm comfortable with it. Hopefully you guys can follow that and try it on your own too to make sure you understand it. All right, so you have divided this polynomial by x minus 1, or x minus 1/2. So we can write this polynomial as x minus 1/2 times, okay, taking my answer, remainder, constant, x, x squared, 2x squared, no x, minus 4. And so we want to know the zeros. We want to know when that equals 0. Well, here's the clear one that we already had, the one at 1/2. This factor, then, we can solve to figure out what makes that equal 0. Okay, you might factor out a 2 and factor a little bit. That'll give me x squared minus 2, which isn't a difference of squares, so I can't factor further. But I can solve this because it simply has an x squared. It doesn't have any x terms, so I could get that x squared alone. 2x squared equals 4. Divide by 2, x squared equals 2. Take the square root. Remember that that gives me two solutions, positive or negative. Square root of 2. I get my 3 zeros in their exact form. Okay, not that decimal approximation that we would have needed to have from our calculator. All right, let's try this one more time. Okay, we need to find any rational zeros to be able to do this. And we want to list out all the ones that we have. So here, go ahead and go to your calculator and find your zeros. See which ones are actually rational zeros. Try all 4 of them, because there are 4. See which ones are rational and list them out. So pause this and try it. Okay, hopefully you found x equals 1 and x equals a negative 1/2. All right, so we're going to go ahead and work through and solve. What we know so far is that we've actually got some factors of this polynomial. I can write this as x minus 1 times x plus 1/2. So I can do my synthetic division using 1. We'll start with one of them. Set up my polynomials. So negative 1, negative 7, 3, and 3. Okay, pause it. Try this. Do it on your own. Actually, I have to come back to the next video because I'm looking like I might run out of time. So I'm going to stop it here. You try that, finish that up, come to the next video.